Okay, today we're going to be talking about distance and displacement. It's the first topic we'll be studying in mechanics. Well, what is mechanics? Well, first we have to understand what kinematics is. Kinematics deals with the concepts that are needed to describe motion. For example, how fast something's moving, whether it's accelerating, which direction it's moving in. Dynamics deals with the effects that forces have on motion. What causes things to speed up, slow down, change direction. Both these ideas together are what's called mechanics. Alright, so let's talk about our first word, displacement. So what is displacement? It's not distance, it's a little bit different, it's a little trickier. To find out displacement, you would take your initial position. For example, in this case, you started right here. Your final position, and you would subtract those two to find out your displacement. In other words, displacement is equal to your final position minus your initial position. So let's give an example of this. All right. Let's say you have an initial position, x sub 0, of 2 meters. You end up having a final position of 7.0 meters. What's our displacement? Well, delta x, or displacement, is equal to the final position minus the initial position, or 7 meters minus 2 meters, for a total displacement of 5 meters. In other words, you went from here and you ended up here. So you had a displacement of 5 meters. But they always don't have to be in the same direction. For example, let's look at another one. Let's say you started at 7 meters. You ended at 2 meters. So obviously you had to go backwards to finish up. So let's see how you do your displacement this time. Your displacement is equal to final position minus the initial. You ended at 2, started at 7, so you have a displacement of negative 5. In other words, you walked backwards in the opposite direction of what you called positive, and had a displacement of negative 5 meters. Okay. All right. Let's say, for example, you started in the negative region. You started at negative 2 meters. You ended at 5 meters. What is your displacement? Once again, you take your final position of 5 minus your initial position of 2, or negative 2 in this case. You subtract the 2, and you end up with 7 meters. So your overall displacement was positive 7 meters. All right. As you can see from the last example, we walked a total distance of 2 meters plus 7 meters, or 9 meters. Notice the direction does not matter, only the magnitude. Like, we didn't worry about this would be negative 2 or this was positive 7. We just worried about the magnitude. So in other words, distance is how far you walked, while displacement looks at only at your ending and starting positions. Give an example. If you run all day around a track and end up in the same location you started at, then your displacement is 0 because you ended at the same place you started at. Even if you ran 26.2 miles, which honestly is a marathon. Okay, think of it this way. Here's another example. You wake up in the morning, you get out of bed, you may move 4 or 5 miles easily in a day, but you end up in the same exact bed you started at, so your displacement at the end of the day is 0.